Right. Ladies and gentlemen, Your Excellency, the British High Commissioner in Cyprus, distinguished guests, dear colleagues, I'm very happy to welcome you here today for the newest installment of the Ronald Ross lecture series, which is co-organized by the British High Commission and the Cyprus Institute. It was interrupted for more than a year because of COVID, and we're very happy now to be back online with this very exciting presentations that we are going to have today. I would like to thank, in particular, the British High Commission for their support and their cooperation throughout this process. I would like to thank, of course, our speakers, Professor George Christophidis and Professor Andrew Haines, and of course all of you for being here today to talk about this very, very relevant and very important subject. Before we start with the presentations, I would like to invite His Excellency Mr. Stephen Lilly, the British High Commissioner to Cyprus, to say a few words. Your Excellency, the floor is yours.
Well, thank you very much, and Professor Andy Haines, ladies and gentlemen, good evening. It is a real pleasure to add my own words of welcome to this second lecture in the Ronald Ross lecture series. In the High Commission, we were delighted when back in 2019 the Cyprus Institute proposed having this annual UK Cyprus lecture series. It is, I think, really a special addition to what is admittedly already a very rich web of links between Britain and Cyprus in the fields of education, science, innovation and research. We will hear a bit more about the history of or the connection to Sir Ronald Ross, but suffice to say that Sir Ronald was the British scientist who received the Nobel Prize in 1902 for his work on the transmission of malaria in Asia and Cyprus. The lecture series aims to bring to Cyprus in person or this year online eminent British scientists who are leaders in their fields. And we're absolutely delighted to have Professor Sir Andy Haines here with us today. I'll let our friends from the Cyprus Institute introduce Sir Andy properly. But I would say that at a time when our lives are still in many ways dominated by the impacts of the global COVID pandemic, and as we look forward to the international climate change negotiations in November, there are a few better qualified people than Sir Andy Haines to speak to us tonight on the subject of climate action for health. Now, as I've alluded to, in less than 8 weeks from now, the UK will welcome the world to Glasgow in Scotland for the 26th UN Climate Change Conference, or COP26 for short. We have more than 190 world leaders travelling to Scotland for talks that many have described as our last best chance to avoid catastrophic and irreversible global climate change. We're doing this not for the first time, of course. 5 years ago in Paris, the international community agreed to limit global temperature rises to well below 2 degrees, to cap them at no more than 1.5 degrees. And yet since then, we have collectively just not done enough. The planet continues to heat up. And here in the Eastern Mediterranean, we've witnessed that for ourselves, with rising temperatures leading to hotter, drier summers, with increased drought, deteriorating air quality, adverse impact on agriculture and marine ecosystems. This year, we witnessed the worst forest fires in the history of independent Cyprus. So it's evident that climate crisis is not some abstract threat in the future, but a very present reality that is already upon us. So for our part, the UK government has been absolutely clear in our ambitions for Glasgow to secure a global goal of net zero carbon emissions by 2050, and to put ourselves on track for that by halving global emissions over the next decade. But as well as agreeing the commitments to achieve this and marshalling the finance to support it, we also need concerted international action to protect people and nature from the impacts of climate change that are already on us. And of course, this does include responding effectively to the public health impacts, from the direct impacts of deaths caused by extreme heat or changing patterns of vector-borne diseases like malaria and dengue fever, to the indirect health impacts of climate-driven poverty, conflict, and migration. As the UK, we're absolutely committed to working globally, and that means working with our friends in Cyprus. We look forward to welcoming President Anastasiades, Environment Minister Cadiz to Glasgow, and we look forward in particular to the International Conference on Climate Change in the Mediterranean and the Middle East, which will take place here in Cyprus in October, just ahead of COP26. Cyprus Institute has been the real mover in ensuring that that happens. I'm sure it's going to be a real opportunity to coordinate climate action in the neighbourhood, to encourage the necessary mitigation and adaptation steps for a safer, more sustainable future. I just want to conclude by adding my own thanks, above all to Professor Sir Andy Haines for agreeing to be our speaker this evening, to the Cyprus Institute for partnering with us on the lecture series and indeed doing all the hard work actually making it happen tonight. So we really appreciate that. And finally, to all of you, our virtual audience for this second Ronald Ross lecture, thank you to all of you. I wish you all an insightful and thought-provoking evening. Thank you very much.
Your Excellency, thank you very much for those kind words. I will now introduce Professor George Christophidis, who himself is a wonderful example of cooperation between the UK and Cyprus. He is Chair of Infectious Diseases and Immunity at Imperial College in London, but also an adjunct professor here at the Cyprus Institute, and until very recently, the president of our institute. So Professor Christophidis, if I understand correctly, you will give us a little bit of context about the person behind the name Ronald Ross, who gave his name to this lecture series. So Professor Christophidis, the floor is yours.
Thanks, Nick. Hello, everyone. Welcome, Andy, Your Excellency, High Commissioner, dear friends. Yeah, so the idea is that I will give you some context of this connection between Ross and Cyprus and why the Cyprus Institute, together with the High Commission, has embarked on this collaboration for this lecture series. So let me see whether I can share my screen. Do you see the man on the screen? You do see, right? I guess the Ronald Ross. So Ronald Ross was a complicated man. So he was eccentric, egocentric, impulsive, like many scientists, more or less. So also multi-talented, a military man, a surgeon, a poet, a writer, a devoted husband, a father, and above all, a great researcher, one of the greatest of his time. So he was born in colonial India to a general of the British Indian Army in 1857, and was sent to England to study and become a surgeon at St. Bartholomew's Hospital Medical College, trained then at the Army's Medical School, and then appointed a surgeon in the Indian Army Medical Service, and posted in various places in the Indian subcontinent. So being born and practicing medicine in India, he was acutely aware of tropical diseases that tantalized public health, such as malaria, leishmaniasis, filariasis, and many others. So he took a study leave and went to London to study and obtain a diploma in public health. So during a home leave, a bit later, from India to London in 1894, he met Sir Patrick Munson, the father of tropical medicine, and also the patron and one of the first presidents, possibly the first, Andy, correct me if I'm wrong, of the London School of Tropical Medicine, and who had trusted him with his mosquito malaria theory and mentored Ross to investigate that. So a few years later, Ross revealed that the malaria-causing parasite is transmitted indeed between humans through the bites of mosquitoes, and for this he received the Nobel Prize in 1902. So let's see, I can see screen. Yeah, so I told you Ross was a good poet. So in the evening of his initial discovery, he began composing a poem which he finished the day his paper was published in the British Medical Journal. So being aware of the major significance of his discovery, Ross wrote, "This day relenting God hath placed within my hand a wondrous thing, and God be praised, at his command seeking his secret deeds, with tears and toiling breath, I find thy cunning seeds, O million murdering death." So he recognizes how significant that is. And I know this little thing, he says, a myriad men will save. O death, where is thy sting, thy victory, O grave? So 125 years later, Ross's discovery continues to guide us in controlling malaria in the developing world. And this discovery was monumental at the time, not only because it was a lifesaver, but because of its practical importance for the British Empire at the time and other empires, other great powers. So indeed, by the time the empire collapsed, malaria was eradicated from many countries, largely thanks to the discoveries of Ross, who himself was commissioned by the Houses of Parliament and the King to advise on malaria eradication from West Africa, the Suez Canal, Mauritius, Greece, and Cyprus. So Ross visited Cyprus a few times, starting in 1913, when the High Commissioner of Cyprus at the time, Major Sir Hamilton Gould Adams, requested from the government to send a medical expert to help with the scourge. So Ross, together with officials and medical personnel working with the Office of the Colonies, visited most of the island. I mean, you can, if you read his notes, it's incredible. He went to every village in the island and examined the spleen of all the children there and assessed the malaria situation. So he kept excellent notes that, together with the hundreds of photographs he took, attest for the major problem of malaria that was at the time in the island, and are an excellent historical and traveling record for of Cyprus. So he advised the Cyprus administration on how to deal with the problem through draining of swamps and getting rid of mosquito breeding sites, etc. But the best Ross did for the island was that he identified, trained, and mentored a young, very ambitious Turkish Cypriot from Kalokoryo, Larnaca, named Kemal Aziz. So Aziz was appointed at the Department of Medical Services, organizing mosquito control in the island, and in 1930s and 1940s became the chief medical inspector of colonial Cyprus. The progress in the first decades was small due to the lack of funds that the empire was putting into Cyprus, but later, when funds became available, Aziz formulated a meticulous plan to eradicate the disease. So he divided the island into 500 grids, each to be covered by a single worker over 12 days, with the sole aim to eliminate mosquitoes, pouring a thin petroleum film on water surfaces, preventing the mosquitoes from hatching. So after 3 years of painstaking work, Cyprus became one of the first malaria-free countries in 1950. So Aziz was hailed as a hero, the great liberator for the Brits, the flying man for Cypriots, and it was awarded the title of the Member of the Most Excellent Order of the British Empire for his work. Soon after that, the Cyprus struggle for independence from the British rule started, followed by the long civil unrest between the two communities, which led to the invasion by Turkey and division of the island that you all know. And Aziz, one of the greatest heroes of Cyprus at times of peace, being a Turkish Cypriot and chief health inspector in colonial Cyprus, was totally forgotten by the people in the Republic. So perhaps the Cyprus Institute and the High Commission could use and capitalize on this collaboration for the Ronald Ross lecture series to identify ways to honor the memory of this great Cypriot. Finishing, the great challenge, possibly the greatest in all human history, that we now face is climate change. A challenge of existential threat, as we'll hear, I guess, from Sir Andy, indeed. which has already and will continue to affect our planet in general and the region of the Eastern Mediterranean and Cyprus in particular. The impacts of climate change on human health will be enormous, amongst them projected dramatic increase of the spread of vector-borne diseases like the ones that Ross and Aziz have worked with. And the mission of both scientists and policymakers is equally huge and critical. So I wish to also thank, from my part, Professor Andy Haines for accepting our invitation to give this Ross lecture, which I'm very much looking forward to. Thank you. Thank you, Andy.
Thank you very much, Professor Christofidis. I would now like to introduce Professor Haines. It's really a great privilege to have you here today with us to deliver this lecture. I want to tell you a little bit about Professor Sir Andrew Haines, he is a professor of environmental change and public health at the Centre on Climate Change and Planetary Health at the London School of Hygiene and Tropical Medicine. Professor Haines was formerly a primary care physician and professor of primary health care at UCL in London. He developed an interest in climate change and health in the 1990s, and he was a member of the Intergovernmental Panel on Climate Change for the second and third assessment exercise, and a review editor for the health chapter in the fifth assessment. He was the director and formerly also the dean of the London School of Hygiene and Tropical Medicine from 2001 to 2010. He chaired the scientific advisory panel for the 2013 World Health Organization World Health Report, the Rockefeller-Lancet Commission on Planetary Health in 2014-2015, and the European Academy's Science Advisory Council Working Group on Climate Change and Health in 2018 and 2019. Currently, he co-chairs the Inter-Academy Partnership, which includes 140 science academies worldwide. He coordinates the working group on climate change and health, and he's also co-chairing the Lancet Pathfinder Commission on health in the zero carbon economy. He's published many papers on topics such as the effects of environmental change on health and health co-benefits of low carbon policies. His current research focuses on climate change mitigation, sustainable healthy food systems, and complex urban systems for sustainability. Professor Haines, I'm going to hand over to you for our lecture tonight. Thank you very much for being with us.
Well, thank you very much for the kind introduction, and it's a great honor for me to speak tonight at the Ronald Ross lecture. Can I just first of all check that you can hear me and see my screen?
Yes, we can.
Good. What I'm going to do is to give you a brief overview of a complex and evolving topic, which is both fascinating and disturbing. I'm going to talk a bit about the impacts of on health of climate change, but also importantly, in the second half of my talk, I'm going to discuss the actions that we can take to reduce the impacts of climate change on health, both to foster adaptation to climate change as far as that's possible, but also to mitigate, in other words, to cut greenhouse gas emissions in order to reduce the risks of dangerous climate change. So let me start by just showing you this slide, kindly sent to me by colleagues Zitis and Lillefelt, who are publishing this paper on the climatic trends in the Eastern Mediterranean and the Middle East. And what you can see from this slide is that the Eastern Mediterranean and the Middle East is really experiencing more rapid change, more rapid temperature increase than many other regions of the planet. So as I think most people know, we have reached a state where we are about 1.1 degrees centigrade global average temperature increase above the pre-industrial times. And that's due to the emissions of greenhouse gases, largely carbon dioxide, about 70%, but also what are called short-lived climate pollutants like methane, which stays up in the atmosphere for about 12 years, black carbon, which is a kind of sooty particle, and other shorter-lived climate active agents. So you can see then that the Eastern Mediterranean and Middle East is particularly experiencing these high rates of temperature increase, and it's a vulnerable region. It will have wide-ranging impacts on the health and well-being and the future development of the region as a consequence of climate change. And so it has a particular interest, really, in fostering policies that lead to rapid climate action. And as we've already heard in the introduction, we're really running out of time to reach the limits of the Paris Agreement, well under 2 degrees heating. And at the moment, we're very far away from that trajectory. Just today, I heard a report suggesting that it's more likely that we'd be at 3 to even 5 degrees global average temperature by the end of the century than 1.5 degrees, which is sadly slipping out of our grasp as we are speaking. So what are the impacts of these rising temperatures? Obviously, these bring with them rising risks. They threaten ecosystems. It's very difficult for ecosystems to keep pace with this rapid temperature change, which is far in excess of the rate of change that any natural system has experienced in the past. Extreme weather events, particularly floods, droughts, extreme storms, also increase in frequency and intensity. There's the potential of large-scale singular events, such as collapse of ice sheets, which would dramatically, of course, increase sea level rise. Coral reefs are dying off, and coral reefs are important parts of the ocean ecosystem. They provide fish nurseries for young fish. They provide sustenance and occupation and labor for many tens of thousands of people. Some parts of the world are warming up quicker than others, like the Arctic region, for example. As we heat the sea and as we melt the ice caps, of course, there's increased coastal flooding, river flooding, because the atmosphere holds more water as you heat it up. And these effects will all have implications for human health through, for example, declines in crop yields, and also these more direct effects of heat-related morbidity and mortality. So this shows you where we are. This slide is only a few months old, but even now it may be outmoded. And I'm concerned that this optimistic scenario, which in itself is not sufficient, but at least on the right track of 2.1, is far too optimistic for the direction in which we're traveling at the moment. We're seeing a marked reluctance on the part of many of the key players to actively decarbonize their economy, to actually phase out fossil fuels and other sources of greenhouse gas emissions, because, of course, there are large vested interests that are opposing change. And influencing public opinion, of course, is not always easy. So there's a lot more that we need to do, and I think that the health community can play a very important part in increasing and accelerating ambition for deeper cuts in greenhouse gas emissions by reframing climate change from an environmental problem to a health problem. So what are the implications for human health? Well, they're complex, as summarized in this slide from a paper we wrote a couple of years ago. And this tries to summarize a complex picture, shows you how the increasing levels of CO2 and these short-lived climate pollutants lead to changes in climate, depending on demography, on socioeconomic status, other environmental trends. These all influence the magnitude and the pattern of risks. And these then impact on human health through a range of different exposure pathways, which range from the most direct, like extreme weather events or heat stress, through to the less direct, like changes in air quality, for example, through wildfires, water quality and quantity, food supply and safety. We've already heard about the changes in the distribution of vectorborne diseases and changes in their ecology. And of course, the most difficult to model and to quantify are those impacts through socioeconomic systems, like increasing poverty, for example, displacement of populations, perhaps violent conflict. We know from the World Bank that if we fail to act, over 100 million people could be forced back into poverty over the coming decade because of climate change. So there are potentially very big stakes here in the climate change agenda. So it's helpful, I think, to divide these impacts into the three broad areas: the direct effects, effects through natural systems, and the effects through socioeconomic systems. And they become more difficult to quantify as we move towards the less direct effects. What we do know, of course, we have some experience. We know that in the European heat wave of 2003, which was an extraordinary event, which hasn't been repeated so far at quite the same intensity, but will become, as the figure at the bottom of the slide shows you, will become increasingly the norm as the century goes on. But there were probably about 70,000 or so excess deaths as a result of that heat event, some of those directly due to health, some due to the health effects of climate change, some indirect from the impacts on healthcare systems and so on. In France, there are about 15,000 excess deaths, and a paper suggested that human-induced climate change was responsible for about 70% of the heat-related deaths in central Paris, rather less in Greater London. So in other words, if we hadn't had human-induced climate change, those deaths almost certainly would not have happened, because the event, the intensity and the duration of the event was far in excess of what we'd expect as a result of natural causes. This book, Fatal Isolation, summarized the observation that many of the people who died were isolated, sometimes elderly people, living in air-conditioned apartment buildings, often at the top of old buildings with the hot air arising around them, and sometimes in residential homes, which in those days were very poorly equipped with air conditioning and cooling devices. So that was an example to us of what can happen if we don't adapt and take into account extreme heat exposure. A recent paper has taken forward this research agenda considerably, because we're now in a position to speak more confidently about what we call attribution of these deaths, heat-related deaths, to climate change. In other words, they're not just due to random fluctuations in naturally occurring temperature fluctuations. They're due to the greenhouse gases that we, human species, have put in the atmosphere. This is a paper that came out in Nature Climate Change just a few weeks ago, based on data from 730 plus sites in 43 countries. And what it shows you is it shows you where the heat-related mortality rate can be attributed to human-induced climate change. The color of the red shows you the intensity of the attribution. But interesting enough, of course, there are some big gaps. So we don't know what's happening in much of Asia, in Russia, and in much of sub-Saharan Africa. But where we do know what's happening, we believe that about 30% or more of the total heat deaths over recent decades can be attributed to human-induced climate change. Obviously, we can adapt up to a point, and human populations are adapting around the world, but there will be limits to adaptation. There will be physiological limits, psychological or behavioral limits, technological limits to how far we can adapt. And once adaptation stops, of course, things will get much worse much more quickly. And we can't wait for that to happen, because by the time that happens, it will be too late to avert much or many of the catastrophic effects that could occur. But it's not just the direct effects of heat on death rates in adults. It also affects the mothers and children. This is a recent systematic review which summarizes the literature on the topic. Most of these studies done in high-income countries. The situation may well be worse in low-income countries. The odds of preterm birth increases per degree rise in temperature above a particular optimum level, which can vary somewhat depending on where you are in the world. But this shows you that there's a substantial increase in preterm birth per degree increase in temperature. And that gives us an indication that climate change can affect the health of children now and in the future, because some of these changes may be long-standing. And I would just say also that we are starting to do some work in West Africa, where we're looking at pregnant subsistence farmers. And these women are forced to work because they have to feed their family, and they're working in extremely hot conditions that are so hot already that if they were American soldiers, they'd be instructed to rest and given very strict instructions about hydration. But of course, many of these women are unable to do that. And this is having impacts on their fetal health, as we are studying at the moment. So this slide shows us the likely projections forward. And you can see that for a business as usual pathway, there will be unprecedented exposures to these very, very intense heat wave conditions. They could involve temperatures up to 56 degrees centigrade and be of extended duration and potentially life-threatening for humans. And it will be very difficult, of course, to adapt to these kind of conditions. So by the end of the century, depending on the decisions that are taken over coming years, about half of the population of the region could be exposed to these events annually, which of course is a very frightening prospect. Of course, we can put in air conditioning, but air conditioning itself has problems. It depends on reliable electricity. It demands much more energy. Fossil fuels have to be burnt. It increases air pollution, greenhouse gas emissions. And of course, you've got to pump the air somewhere. So you have to pump it out into the outdoor space, and that makes the urban heat island worse. So the urban heat island is the name given to the fact that cities tend to be hotter than the surrounding rural areas because the buildings reflect and radiate heat, particularly during the night, roads, buildings, and so on. That can be modified by green space, by planting trees, perhaps by water as well to some extent, although water can also radiate heat at night. So the way in which we design the cities of now and of the future can influence their vulnerability to extreme heat and extreme weather conditions. So we know that the urban heat island can increase the temperature of the city by several degrees compared with the surrounding areas. And even within the city, there can be variation of several degrees, which are actually important from a health point of view. Under some high emission scenarios, some cities could be 7 degrees hotter than they are currently by the end of the century. And it depends very much on which emission scenario we look at. So there's a lot hanging on the kind of decisions we make over the next few years. A recent review of papers has shown the increased risk of wildfire from climate change. And interestingly, of course, this doesn't just affect poor populations. We've seen wildfires in California, devastating wildfires, in Australia, in parts of Europe, of course, including Greece. So wildfires can have pervasive effects on health. We believe that wildfire smoke is more toxic than the kind of standard, if you like, urban air pollution, which is, of course, bad enough. But these particles are smaller on average. They penetrate deep into the lungs. They contain more oxidative components like polycyclic aromatic hydrocarbons, which are damaging to health. And they have pro-inflammatory components that can trigger inflammatory responses in the body. So they are more damaging to human health than many other forms of air pollution, we believe. And they also have devastating effects, of course, on biodiversity. We've seen vast numbers of deaths in the Australian fires and the Californian fires and so on, of wildlife, much destruction of forests and so on. Climate change has impacts on the productivity of food systems. You can see on the right here, the red areas where crop yields are going to decrease by mid-century. And you can see that much of the world is affected, including parts of the southern Mediterranean, of course. It's possible that in temperate regions, crop yields may increase for a time, but we don't know how long that will go on, and we don't know whether people will be able to afford to buy food on an increasingly competitive global market. And on the left, you can see modeling studies, their projections that they give us, and these tend to agree that the climate change impacts on crop yields will be negative, or perhaps a decade from now. It will be substantially negative. And nearly half of the projections beyond 2050 suggest decreases greater than 10%. So that's really, really substantial. These are not trivial decreases. This could have a big impact on nutrition and on food prices, food security, and so on. We also know it's not just the quantity, it's also the quality. So as you put CO2 into the atmosphere, that can stimulate the growth of some types of crops. But it also dilutes the micronutrients. So zinc and iron, which is important for health, both of which are. About 2 billion people have micronutrient deficiencies, and the crops are likely to become less nutrient loaded in the future as a result of CO2 emissions increasing. So that's on top of climate change. Not just staple crops. We also believe that fruit and vegetables will be affected as well, particularly by growth, reductions in their growth. And fruit and vegetable consumption are very important for human health. Adequate consumption, 400 grams a day, is necessary to prevent many non-communicable diseases like heart disease and some types of cancer. But as we've already heard, of course, climate change can have pervasive effects on infectious disease risks. And this is a paper from colleagues in the WHO, so the ECD Centre, the European Centre, a few years ago, led by Jan Semenza. And they looked at the drivers of infectious disease threats. This one's about vectorborne diseases in Europe. So this is not the very low-income countries, the most vulnerable, but in Europe. And you can see that, if you look along the top, you can see that many of these are triggered by natural environmental changes, like land use change, for example, and also, importantly, climatic changes. So climate changes are responsible for changes in the distribution of ticks, of mosquitoes, vectors of diseases like dengue, Aedes albopictus, for example, which was introduced into southern Europe by the trade in used tires, but is now spreading in southern Europe. So these factors can interact to increasingly drive infectious disease threats in Europe, and we need to be vigilant about those. And this is an example of dengue. We've already heard about dengue, very important vector-borne disease, of course. Climate change is expected to increase the proportion of the global population from perhaps about 35% a couple of decades ago to 50 to 60% by late century, depending on the trajectories of CO2 and other greenhouse gas emissions. And we know that already the capacity of vector mosquitoes to transmit dengue, vectorial capacity, has already increased by about 10%, something of that order, as a result of the climatic changes already experienced, something of that. That gives you an indication of the changes already experienced. So dengue is not just due to climate change, there are many other changes as well that are driving it, but it's a typical disease which has a multifactorial origin. The vectors are affected by a number of environmental influences, but climate is certainly in there as an important factor. But it's not just, of course, the physical effects of climate change, it's also the mental health effects of environmental change. And we've experienced that with COVID very much. So COVID obviously is a pandemic, but it's had profound effects on mental health and on a range of non-communicable diseases because the way in which it's disrupted health systems, for example. The mental health effects of environmental change can be due to floods, wildfires, droughts. Many studies have shown an increase in common mental disorders after these extreme events. There's this term solastalgia, the distress, the grief, some people have called it, the grief caused by environmental change, when people see their familiar environment changing before their eyes in very negative ways. People living in the Arctic that are forced to move their communities because of melting ice might be one example of that. And there's also this intriguing association between historical temperature records and suicide rates, as summarized by this paper in the US and Mexico. Some of that may be due to declining crop yields. There may be other factors involved as well. So there are a number of pathways by which climate change can impact on mental health. And of course, impaired mental health can impair our responses to climate change if people are depressed, low mood and so on. And this slide of a systematic review of the health effects of drought indicates some of the complex pathways. So drought can impact on vector-borne diseases, changing transmission patterns, the mental health effects I've mentioned, nutrition-related effects, airborne dust, smoke, for example, from wildfires, and of course water-related disease as well. But all of that feeds into increased morbidity and mortality and interacts. So that's just one example of the complex relationships within particular events. And of course, there's been a lot of speculation about the relationship between climate change and migration, both internal and international migration. Still quite uncertain and still controversial in some degree. But this study, published a few years ago in Science, suggested that EU applications might increase under climate change. It was based on associations between the growing temperature in the growing season of the countries from which EU asylum applications normally come. And they showed, the investigators showed that once you exceed a certain threshold, that the increase of asylum applications increase. And based on that, they projected forward. And you could see that there could be substantial increases in asylum applications, obviously quite considerable uncertainties as well. So what do? Well, we have to act in two separate ways, but interrelated ways. We have to adapt as far as we can to climate change. And as I've mentioned, we can adapt up to a point, but there will be limits. There are many ways in which we can do that. We can have better disaster management systems. In Bangladesh, for example, they've been very successful in reducing their death rates from extreme storms through the provision of early warning systems and storm shelters, for example. So it can be done up to a point. Flood protection, infrastructure upgrades, more resilient local food systems by creating urban forests that can be catchment area for flood water and so on. So there's a number of things that we can do, but we also have to cut greenhouse gas emissions. And that's probably the most effective way of reducing our exposure to dangerous climate change. And that can be done, of course, by moving towards clean, sustainable energy, more energy efficiency, sustainable transformation of transport systems, and so on. And increasingly, we need to adapt and mitigate in a coherent and integrated way rather than seeing them as two completely separate types of policies. This is just an example of how integrated early warning systems could work. Better knowledge about disaster risks, better detection, monitoring and analysis and forecasting, dissemination and communication to the public. You have to get out to the vulnerable communities. You can't just issue a weather warning. You have to ensure that you have volunteers, primary care systems that can reach out into the community and make sure that the vulnerable people are alerted and are taken to safety. So you need preparedness at all levels to respond. This is a paper from The Lancet just in the last week or so showing how community health heat action plans can help to reduce heat-related health risks. So the health sector can lead, but it needs to engage other sectors, needs to engage in communication, education, I've mentioned, integrated surveillance and early warning systems, I've mentioned. The community response measures are important, including cooling centres, distribution of water, and targeting vulnerable groups. Creating more climate resilient health systems which can withstand climate shocks. And in terms of cities, there are three kind of levels, if you like. We can respond at the landscape level by greening our cities, at the building level by having things like cool roofs or shutters, or passive cooling that doesn't require air conditioning with its energy-hungry air conditioning, and at individual levels by ensuring adequate hydration, and taking shade and rest and so on, and making sure that these vulnerable groups at the bottom of the slide are also included in plans. So these are the kind of steps we need to be taking for a 1.5 degrees world. And you can see they're very, very ambitious, renovating buildings 3 to 5% a year because many of our buildings are obsolete. They're based on the fossil fuel economy. They rely on large inputs of fossil fuels, and we need to really decrease our dependency on those. New buildings should be zero emissions from 2020, and there isn't much sign of that. The best practice in agriculture can reduce emissions from food systems, but also create more smart agricultural systems, more resilient crops and livestock. Cut deforestation, because deforestation is also contributing to climate change. And we also need to develop a vision for aviation and shipping, which will be technically very difficult. And of course, low carbon transport, both electric vehicles, which of course is technically possible, but won't be easy to scale up and make affordable. And also, where possible, active travel and public transport. So there's a lot that we can do, but we're not doing that at the desired effect, at the desired pace. To give you a few examples of the kind of benefits of a zero carbon economy, one is if you phase out fossil fuel burning, we'll reduce greenhouse gas emissions, obviously, but we also prevent many premature deaths. And this estimate, with Jos Deleveld leading this particular team, suggested about 3.6 million premature deaths a year could be attributed to the ambient air pollution from fossil fuel burning. And when we stop burning fossil fuels, those deaths could be prevented. And the colour of the shading on the map shows you where the deaths could be prevented. Many in Europe, many in India, China, and in North America. Less so in Africa because they don't burn so many fossil fuels, but of course they may do in the future depending on the trajectory of development. So big benefits, and these benefits are over and above the benefits of reducing the risk of dangerous climate change, and they will occur in the near term as well as in the longer term. We also know there are other air pollutants, nitrogen dioxide. This recent paper from Delevald's group, and a number of us collaborating on that, look at nitrogen dioxide. Nitrogen dioxide is important because it's believed to trigger asthma amongst children and adolescents. And this paper shows how we can attribute the incident cases of asthma to exposure to ambient NO2. NO2 comes from the transport sector. Depends on the country. Transport sector is a common source. Natural gas burning as well is quite common, so burning of some fossil fuels as well. So if we reduce dependence on those sources, we can also reduce the adverse effects of nitrogen dioxide, including on the health of children. Reducing food waste and promoting healthy, sustainable diets. We know that about 30% of the world's total agricultural land is used to produce food that's never eaten. A lot of food loss in poor countries and food waste in high-income countries. We know that predominantly plant-based diets reduce the burden, the environmental impact, and are also healthier diets. But of course, there's some populations, animal products may be important sources of micronutrients. So we need to be sensitive to different cultural patterns and also to different needs, nutritional needs of different populations. But overall, moving towards a predominantly plant-based diet with less, particularly red meat and dairy products, particularly in high-consuming countries, will bring environmental benefits and human health benefits. And we need to think about ways of encouraging this dietary shift and making it more culturally acceptable and easier choice, so the healthy choice becomes the easy choice. This is an example of active travel, low carbon transport, some work we did some years ago, showing the benefits of getting the population of England and Wales walking and cycling at the population of Copenhagen in Denmark, which has very high levels of walking and cycling, as you may know. And we showed the potential big benefits to our National Health Service. This is eventual reduction in costs. That's why the lines go up. This is a number of the potential NHS expenditure averted by year. And you can see potential big benefits from reduced diabetes, dementia, heart disease, stroke, and some types of cancer, and possibly depression as well. Now, of course, in hotter climates, that's not so easy. But we also know that electric bicycles can help to encourage physical activity by people who are generally more sedentary, and also they require less energy expenditure than other bicycles, and they still produce very useful levels of physical activity. So there may be other technical solutions that can be introduced even in relatively hot climates. We know that redesigning our cities to increase green space and reduce traffic is beneficial to health. This is the example of Barcelona. They've developed this superblocks concept where they've amalgamated city blocks, 9 blocks into one superblock, prevent people from driving through. You can walk and cycle, but you can't drive through except to access your house. They've planted more trees, and they've calculated that if they could scale this up to the whole city, then there could be big health benefits. And on the left, you can see some of the benefits have been assessed by scientific literature, and the black typing shows you where there's good evidence, and the grey shows you where there's some evidence, but it still needs more work. And you can see there's quite good evidence for adults and some evidence for children, but it's very much an emerging research field to try to evaluate the health benefits of green space. Green space helps to cool the city, as I mentioned, also traps air pollution to some extent, but also because when trees and vegetation grows, it can lock in carbon, take up carbon from the atmosphere. We're also realizing the healthcare sector is a major emitter. If you put the whole global healthcare sector together, it would be the 5th largest emitter of greenhouse gases on the planet. And some healthcare systems are now taking the leadership. NHS England has committed to net zero emissions by 2040 for these direct emissions, and 2045 for the indirect emissions, like the supply chains. So we know a lot of emissions that are embodied in the pharmaceuticals, which are very energy intensive, in medical equipment and other supplies. So healthcare systems have to work with the suppliers. Their procurement policies need to address both environmental sustainability as well as driving down the price as far as possible. And that is what is happening in an increased number of cases, that healthcare professionals and healthcare purchasers are working with the private sector to incentivize them to drive down their emissions in their supply chains and work together to decarbonize the healthcare system. And there's a lot that can be done to foster that. We'll come back to that perhaps in the discussion. So in conclusion, and to stimulate the discussion, let me just say that climate change, I believe, does have a range of very worrying and potentially catastrophic effects on human health if it's left unchecked. The degree to which these happen will depend very much on the decisions that we collectively, humanity, make over the next few years, decades. That's all we have. There are pronounced inequities because high-income countries have emitted far higher per capita emissions than many low-income countries. And the impacts, of course, will be borne particularly by those living in low and middle-income countries, but not uniformly. No part of the world will be safe from climate change. It'll all be affected. So there's a real opportunity now for the health sector to engage in this race to zero, which is a kind of coalition of actors, 120 countries, businesses, universities and others, cities, in supporting a collective effort really to rapidly phase out greenhouse gas emissions and move towards a much healthier and sustainable trajectory of development in order to safeguard health over coming decades. I will stop there, but just to leave you with the thought that with COP26, as we've already heard from His Excellency, coming up, there's a real opportunity to try to move the needle, to try to really increase the level of ambition towards reducing emissions of greenhouse gas emissions and other climate active agents, to increase resilience of healthcare systems and other crucial supply chains in our society, and to raise awareness, public awareness, and to influence public opinion towards a cleaner, healthier, low carbon recovery from the COVID pandemic. Thank you very much indeed.
Thank you very much, Professor Haines. I think now we will move to questions that have been asked on the different media platforms while you were actually giving your talk. So I would like to first ask you a question of my own. Going back to the early warning system, it's becoming, I think, increasingly obvious that to have a successful early warning system, to look at the issue of climate vulnerability generally, we need to combine all sorts of disciplines, and in particular the social sciences and the climate sciences. Do you see any evidence of that collaboration happening, or are these fields still very much working in their own boxes at the moment?
Well, it is, thank you for the question, it is very fragmented at the moment. Of course, there are an increasing number of heat action plans, and there are networks, as the Global Health Information Network, for example, which Heat Health Information Network, which works on these kind of issues. So we are seeing it to some extent, but there's still perhaps a tendency to think of it as largely a technical problem. You know, it's just a question of getting the warnings right. And it's much more than that, because it's really about mobilizing the community as a whole. So you have to work with the healthcare system. The behavioral scientists are important because they can tell us how to communicate the message more effectively. Often the most vulnerable people, of course, are least connected to the media. So if you just have warnings going out on social media, that may be great for you know, people, younger people who are very adept at using social media, but for elderly people, or say refugees or others who might be vulnerable, they're much less likely to hear those kind of warnings. So first of all, you need to map out who are the vulnerable groups that you want to influence, decide how the best way of doing that, engage the healthcare system, including the part of it that I used to work in, the primary care system, where people are very much working with patients and communities on a day-to-day level. And they're often the best place to reach out to the vulnerable members of the community. You have to ensure that elderly care homes, for example, are properly equipped, that they have cooling rooms, for example, they're properly you know, temperature controlled buildings, and so on. And so there's a lot of work to be done. We'll have to look at it really in a very integrated and comprehensive way in order to be effective. But if you do that, I think the emerging evidence that we have is that you can reduce the death rates from extreme heat, but you'll never be able to reduce them to zero, because many of the deaths from heat, for example, occur below the level of the heat wave. When you look at the relationship between heat and health, there's an optimum level, and then it starts to go up. And obviously it goes up a lot, it goes up very steeply when you get to these extreme levels of heat. But many of the deaths occur at relatively low levels of heat, because there are many days at that level, whereas extreme events, by definition, are rather rare. So early warning is certainly important, but it's not the whole answer. And you could say the same, I think, about early warning for infectious disease outbreaks and other types of extreme climate events as well. So a lot that we can do, but as you said, it needs to involve the requisite sectors, and they need to be coordinated properly, and they need to reach out to the vulnerable communities. And I think that's where Bangladesh is kind of interesting, because it's had a very high level engagement. So even at the level of the government, the Prime Minister and so on, they have mechanisms for ensuring that there's high level political leadership on, in their case, disaster awareness, warning and preparedness.
Thank you very much. I have a question in the chat here. You talked, you showed very conclusively how climate change is already driving the spread of existing diseases to much larger ranges. The question here that we received is there a way that climate change might also somehow drive the emergence of new diseases or epidemics?
Yeah, that's a really, really interesting question. And of course, there's been some speculation about that. I think that, again, we're probably talking about the interaction between climate change and other factors as well. I mean, we know, for example, that zoonotic diseases, by and large, these are transmitted from animals to humans. They arise largely from the interaction between humans on the one hand, domestic animals and wild animals. So it's this complex relationship between the three. Now that could be influenced by climate change, but also influenced by other factors like food systems, wildlife trade, land use change, deforestation, and so on. So probably it's going to be an interaction of different factors. I think if we do see new emerging diseases coming. And I think the other factor here that a lot of people are becoming interested in is the potential emergence of new pathogens, new in quotes, or possibly pathogens that were experienced in the past but have been frozen from the Arctic, from the melting of the Arctic, the tundra and so on. So there's a recent workshop, one was organised by the European Academies, Science Academies, on the potential for emerging threats from the melting tundra, for example. And that's an interesting speculation. We don't know fully the answer to that, but what we do know is that we need to be looking very carefully because some of these pathogens could be preserved for long periods. So we need to be aware of surprises. We may have some nasty surprises in store, and we have to be very vigilant, looking at the potential places where these new diseases may occur for the first time or reoccur, diseases that we thought were extinct but could come back to haunt us. So yeah, it's a very important question, and we need to invest time, money, and research effort into that.
Thank you very much. We have another question from Shmuel Yerushalmi. It's relating to what you were saying about the loss of nutritional value in crops. What's a possible adaptation solution for this problem? You also mentioned the problem of food wastage, but is there any kind of possible solution on that angle?
Well, one is that having a more diverse diet is better for your micronutrient intake. So some of the problem is that in those populations with low micronutrient intake, they have a very lack of dietary diversity. They might eat a lot of refined carbohydrates, for example. Fruit, vegetable, nuts and seed consumption is very important for micronutrient intakes. So having more dietary diversity is a good thing. Obviously, seafood can help in those populations where seafood is still available. We know that fish are migrating away from the equator, unfortunately, so that some populations that are dependent on coastal fishing, for example, may be relatively disadvantaged in the future. So yeah, dietary diversity, I think, is very important. There's also a lot of interest at the moment in novel foods. So by novel foods, I mean new types of technology, or if you like, repurposing some types of food, like insects, for example. I mean, in some cultures, you can't eat insects. It's culturally taboo. But in many cultures around the world, I think about 2 billion people eat insects as part of their culture. Insects can be quite nutritious, actually. So looking at different nutritional sources, novel foods that may be some of the kind of Impossible Burger type, foods that are predominantly plant-based but remanufactured. Some people are concerned because they're ultra-processed foods. They may not be healthy, depending on how they're actually processed. If they're full of saturated fat and salt and sugar, they wouldn't be. But I think you could create some of these novel foods in much more healthy packaging and much more healthy constituents. So I think a number of potential solutions: more dietary diversity, greater affordability of fruit and vegetables, looking for existing food sources that may not be currently acceptable but might be in the future, like insects, for example, feed them even to animals. Aquaculture, where we have decreases in ocean ecosystems, and people are also looking at sustainable aquaculture as a potential solution, but current aquaculture is often not sustainable because they feed fish to fish, which is not a good way of doing it. So a lot of options, a lot of very active research going on. I wouldn't be totally pessimistic. I think there are ways through with the right kind of investment, I would say, in technology, but also in evaluation and in the social science of understanding people's behaviors and dietary choices. Thank you.
Thank you very much. Our next question is actually 3 questions for the price of 1, but I'll accept it anyway. It's more to do about the issue of addressing climate change head on. So the first part of this question is the 2050 deadline for carbon neutrality realistic? Can it be?
You could say, is it realistic? Because it's, yeah, it could be, it's too late, and will it be achieved? Even if we go for 2050? Well, some people say it's a bit too late. We could debate, you know, it depends, because there's quite a lot of uncertainty, but we need, I think, to act on the side of precaution, because what we need to do, obviously, is to avoid tipping points, and we don't quite know where those tipping points are in the climate system. If, for example, you've got massive release of methane from the tundra, you know, from the melting tundra, then that could accelerate climate change, and it could move out of control with the positive feedback loops. So I think most of us feel that it should be a precautionary approach. 2050 is very much the upper limit, if you like. But is that even achievable? Well, of course, it's achievable. It's achievable with the political will. I think it is. But the problem we have at the moment is that there isn't the political will in many societies. And it does require some tough decisions. And it requires some decisions that may not be universally popular. People don't want to be told what to do, what to eat. You know, they're used to certain behavior patterns, and they're used to certain aspirations of high consuming societies. So it will require quite a shift in public attitudes and beliefs. Is that impossible? Well, no, it's not impossible, but it would need a coherent and integrated political strategy. It also needs, I think, a lot of bottom-up engagement. You can't just impose it on people. We also need to look at examples of where societies are moving more quickly. And we know that some societies have been able to create quite high levels of health, healthy life expectancy at relatively low greenhouse gas emissions, per capita greenhouse gas emissions. So we need to learn the lessons of those countries. How have they done that? And and then look at how we can emulate some of these at least partial success stories. So we can do it. It's not going to be easy. It will require pricing fossil fuels and other unsustainable activities realistically to deter unsustainable activities. That will not be universally popular. But on the other hand, it will bring big benefits. And I think the challenge really is to explain that to the public and to bring the public on board. And as far as possible, we need to motivate the public and communities to take action so that the kind of bottom-up action can meet the top-down politically directed action. And a lot of that action is actually occurring not at the national level, but at the city level. So we're finding city leaders, mayors, for example, are much more prepared to make some of these take some of these more dramatic steps, perhaps because they're closer to the people that they represent, the national governments, and they have less big invested interests breathing down their neck to try and prevent the kind of change that we need to see.
Thank you very much. There was more to that question, but in a sense, you've answered all the angles of that question. I guess the angle really was that, you know, is this 2050 deadline the best we can do? And I think you've answered that.
Yeah,
quite
I'd like to say we could do more. You know, we could theoretically do more. Of course we could. But then I suppose we're trying to deal here with what is achievable. I would like to see more rapid action, personally. But I accept that this is what the kind of the international discussions have led us to. It may not be enough, but let's work with what we've got, make sure we can, and try to achieve that if we possibly can.
So we have one more question, and then I think we'll start wrapping up. And this one is more to do with the human being. The question, and I think you've answered that to a great extent in your talk, but the question essentially is which system of the human body is most at risk from climate change? Respiratory, digestive, the circulatory, etc. I think you've answered all angles of that, but if you want to say something more about that.
Well, when you're dealing with a systems problem, it's always difficult to pull out one system from a bigger network of systems. I mean, obviously, in the direct effects of climate change, it's the thermal regulatory system of the body. So you're getting accumulation of dangerous heat in the core of the body, and the body is unable to thermoregulate. So you could argue, well, that at least for the direct effects, that's a kind of crucial system. But of course, it then spins off all sorts of impacts. And many of the indirect effects that I've talked about, like the effects through nutrition and so on, are not necessarily mediated through that system. So it depends on which effect of climate change we're talking about. If it's direct effects, then of course it's to do with the thermal balance of the body, a physiological balance, its ability to regulate core body temperature, and once that exceeds the safe thresholds, then of course you get the potential for adverse health effects very, very rapidly occurring. So that's, I suppose, at the core of the problem, but it's more than that, as I've indicated. Climate change is having an impact through multiple pathways, and there are probably some we still don't understand yet. So let's be aware that there might be some nasty surprises. We need to understand the complex ways in which climate change is impacting on our health. But if you want to reduce it to a simple one, I would say that's probably the simple answer.
Thank you very much. There is actually one more question, and I think we should take it because it's actually rather interesting. Yeah. As you mentioned, taking action requires a huge amount of political coordination at the international level. Now, maybe within the EU that's possible. We've seen that when it wants to, the EU can coordinate quite a large-scale response. But we live in the Eastern Mediterranean, Middle East region. So our next question that came to us is in this region of the world, we have a lot of conflict. We have very little collaboration on such issues. Can you think of any incentives that might be appropriate in this region that might help achieve a region-wide collaboration in the Eastern Mediterranean, Middle East region in particular, which also will be disproportionately affected by climate change itself?
Absolutely. Well, I suppose the incentive of mutual survival might be quite an important one. So, I mean, you're going to have to work together, really, to address these, because these problems move beyond national boundaries. You know, if a country is destabilized because of climate change, it's going to impact on the whole region. If you get these extraordinary heat events that the climatologists and the environmental scientists are projecting, it's going to affect the whole region. And in the end, you know, the region is interconnected. Whether people like it or not, it's just a fact. So they're connected by not just climate systems, air pollution, of course, transboundary air pollution, migrant flows, of course, all of these factors. So if one's trying to be optimistic, I suppose you could say, look, people may have profound differences of opinion and politics and so on, but maybe there's an opportunity to mobilize people around this priority of mutual survival and to say, look, yeah, we have big differences between us, but we have to work together in order to reduce the risk of climate change, both to help us adapt to climate change, but also to cut emissions collectively, because our survival depends on our ability to work in a more or less integrated fashion. So if you're being optimistic, you might say, well, maybe this is the kind of emergency that would help to mobilize people, help to overcome some of these political barriers before it's too late. That may be a naive hope, but I think it's worth holding out that hope, because we do need to find a different way of overcoming some of the barriers that have been seen, these profound barriers in the region. And maybe, just maybe, climate change is an opportunity as well as a dramatic threat to the future of the region.
Thank you very much. And I think on that note, we will end with the question session. I would like to thank you. Really, it was a privilege to have you here and to take the time to answer our questions. I'd also like to thank, of course, our co-organizers from the British High Commission and Professor Christophidis for his intervention as well. I would like to remind our viewers that next on the climate change agenda in our region is our climate change conference in October, and then, of course, in November, COP26, which will be hosted in Glasgow, as His Excellency the British High Commissioner reminded us. I would like to give our three panelists today, the British High Commissioner, Professor Christophidis and Professor Haines, if you have anything you'd like to say before we close this session. We'll start maybe with Professor Haines, because I know you need to go to another appointment.
Well, just thanks really for giving me this opportunity to speak to you all, and really it's a great honour and a pleasure and a privilege to do so. And I think despite the fact that we are faced by very substantial threats, in a sense, pessimism may be a luxury we can't afford, and we have to actually move forward with constructive proposals. Based on science, of course, but accepting that science doesn't have all the answers. We also need to engage communities and the political structures in each country as well. So I'd like to end on a positive note, having also raised the threats. Thank you.
Thank you very much, Professor Haines. Your Excellency, if you have any few closing words you'd like to say. I don't think we can hear you. You have to unmute yourself. Do you want to try now?
I sent a new request.
Okay, sorry.
Okay, yes.
Sorry, it kept saying that I was being muted by the organizer, but I know you're not trying to do that. No, I mean, I'm not in any way going to try and cap or add what Professor Haines has said in that really thought-provoking lecture. I'd just like to thank you again, Sir Andy, for having given your time and shared your insights. And once again, warm thanks to the Cyprus Institute. We've set another high bar for the Ronald Ross lectures. Thank you.
Thank you very much. And Professor Christophidis.
Just to thank Andy for this wonderful talk that sets the pace of what is to come also in the COP meeting. And thank you, Your Excellency, for the collaboration and this continuation of the Ross lectures. And thank you, everyone, for being here.
Thank you very much to everyone. This concludes our second Ronald Ross lecture. Thank you very much and have a good evening.
Bye now.